Okay, thank you very much. Welcome to this presentation. I hope you can understand me clearly. If I'm starting to mumble or sound incoherent, let me know. And of course, we're welcoming all of you to the subsequent BOF on this entire topic, together with Pavel, where you can throw tomatoes at us, talk to us about what should be done, and so on. So, a quick overview, what are we going to talk about? First, we're going to look again at why change at all. And in the second part, we want to talk a little bit about what drove us to write yet another networking daemon and the design goals that we wanted to pursue there and what we believe needs to be in the network management area. All right, so let's go back in time a little bit. Just a little bit, and look where we're coming from. But before, some words of encouragement. Most of you probably know this, so this is a quote from Douglas Adams. Basically, it says, well, whenever you figure out what the world is doing really, then it's going to be replaced by something incredibly more complex and difficult. And this is really what's happening in the network world every couple of years as well. So, back in 1992, the world was flat. It was mostly a disk. So, most of the people I knew and most of the people who were in the Linux community at the time, they had a modem that they were tinkering with and running UECP over it and essentially two network applications, email and Usenet. Configuration was mostly writing a cron job, and the big complexity in there was trying to figure out why your stupid and expensive modem wasn't doing what it was supposed to do. A couple of years later, the scene had changed dramatically. So after a lot of internal struggles, minor wars, and so on, we had IP networking in Linux. Compared to what we have today, it was still somewhat simplistic, but at its core, a lot of the functionality that we have today was there already. We had Ethernet, we had some networking protocols, devices that don't exist anymore or nobody really uses, like SLIP. ISDN was there and went away sometime later, IPX as well. The infrastructure that was sitting on top of that was still very simple, bootp. That was about all you could do, and the rest was scripting. The entire network thing was configured at boot time in a kind of fire and forget mode. You just wrote a script, did something, and then the network was running. And if you really needed to change something at runtime, you just became root, typed in some commands, or ran a script, and there you had it. In 2002, things had gotten more complex. So I'm lying a little bit. So IPv6 wasn't introduced until I think around 2004, but just for the effect of doing things in 5-year steps, I'm lying a bit here. But essentially we had two different IP versions by that time with a lot of added complexity. You can see the infrastructure layer underneath the user space stuff has grown. There was router advertisements, IPv6 mobility stuff, which was a very hot topic at that time, and then it died, fortunately. IPsec was around, and as you can see at the bottom of it, there's a lot more additional interface types that are being supported. Wireless was, in its first incarnation, still doing wireless web, no WPA. We also had become cross-architecture with S390 devices and so on. And most importantly, there were things like bridging and bonding, where you build virtual devices on top of other devices, which started to introduce some problems into the network configuration, like dependencies. When you bring up your device, you have to make sure that all the constituent devices come up first, and then you can build the one on top. And so that's where the first real nasty complexity started to creep into. As a side note, bootp went away and died in some dirty corner and was replaced by DHCP. But still, network configuration was mostly, to a very large degree, a static thing. You had your scripts that you ran, the machine booted, and then you tended to forget about it. Things got more complex, surprisingly. We had additionally some more address configuration protocols like IPv4 0config. IPv6 became more complex. Wireless actually introduced some real security now, WPA, that had its own functionality running on the side of everything else. We had new devices like UMTS or GSM modems that lived in their own world and weren't very well connected. And we started to have some serious in-kernel network users. So I think the first of them, or one of the first of them, was NFS. Later on we got iSCSI, and today we have even more of those. And all of these things, all of these in-kernel network users also have an impact on what we do in user space. Probably one of the most prominent examples was NFS boot, which had its own little bootp and DHCP implementation on the side, trying to bring up your machine with NFS root, which was, yeah, not very successful code. Another thing that started to appear around that time was the divergence between data center and end users. So end users wanted to have it simple, okay? Do you have your laptop? Laptops no longer looked like, you know, one of these big clunky toolboxes as they did in '95, but they were actually like sexy things you could carry around, and you wanted to plug them in and you wanted them to connect to your wireless networks all the time. And that's when Network Manager was originally conceived. The data center people, they didn't want any of that fancy stuff. They don't carry around their machines. They want the maximum flexibility. They want to be able to do to tweak all the knobs that the kernel is offering them. So they're the power users, and that their things diverged quite a lot. So Network Manager was catering to the end user crowd, trying to make things as simple as possible. And when you want to make things simple, then you have to dump down things. On the other hand, the data center people said, I don't want anything dumped down. I want the full power. I want all the 100 knobs that the kernel gives me. And I like to stick to my scripts. So that's where actually the kind of divergence started to happen, which we're still seeing today. In between, the universe changed again. And I kind of gave up trying to squeeze all these boxes in there. And this is a little bit like when you're doing Tetris and you can't rearrange all these boxes. They pile up and then tilt, game over. As you see, even more changes. We have IBFT that we have to accommodate. Fiber channel over Ethernet creeps in and wants to have its own discovery protocol for how you configure it. You have a bunch of VLANs in the game, for instance, and all that stuff. And there are a bunch of technologies that we really haven't managed to integrate at all. Like 802.1x, for instance, for authenticated Ethernet. We're not doing it. I don't think Network Manager is doing it. It is? Okay. And frankly, this whole thing is a mess. We have managed to get by with this separation between having a network management daemon with Network Manager and running the data center still on the IFUP scripts, but this isn't going to work much longer in the future. And this is why we wanted to look at something different and looking at creative ways of addressing this problem again. Apologies to the Network Manager people, but for the past couple of years, the Network Manager experience we had with the regressions and trying to get functionality included was not a happy experience. And so, which was one of the motivations why we decided to, okay, let's start from scratch. What would we want to do? What would we like to see in a network management daemon? Okay, so much for the introduction. And I'm now handing over to Marius for the second half.
Yeah, hello. What we wanted to do is to write a network service that provides the possibility to manage the complex server side and also the user space, end user side. And we wanted to make it a service. So you have a daemon, it's extensible. You can react, unlike with normal shell scripts, you can react to events from the kernel, from the network, and also from the user. And you can share the information. For example, some network changed, the user plugged off the cable, or the connection is lost, so the user gets informed, and the routing has been changed, or similar events. We want it to be architecture independent and cover all the special devices also, but yeah, make it layered at this place. And what we want to do is to make the move from the if-up world to the new world as smooth as possible. Yeah, we started independently, and there were several pieces of code. Olaf started with some monitoring, and then it turned into a REST-based service. It was working, but it was not really nice. And then in the second iteration of this project, we moved to the bus interface. It needed some time to move it, to learn a little bit about, but now the move is done. In the implementation, we make some decisions about how to make it. We wanted to have a daemon or multiple daemon processes communicating with each other using dbus and providing dbus services, and at different layers. We wanted a structured network configuration where you have some closed entities inside of one configuration, and at the moment we use XML for this to create this tree, but yeah, the XML is not so important. It should work mostly stateless. Of course, in case of DHCP, we store the leases somewhere, but the daemon runs and manages the current state. You can give him policies, and on the server side, you can extend it with scripts. And we decided to make multiple services. The main wcatd server process, a command line utility, under the wcatd supplicants, like VPR supplicant, DHCP 4 and 6, and also Auto IPv6. Network nanny. This is some policy daemon which supports interface hot plugging, so you can take one interface, put another one, and match this another configuration or same configuration to another device. Yeah, and finally, we also need something like user interface, graphical user interface. This means a taskbar applet, which we would need help here because we are both from the non-GUI world. Wicked is able to read the ifcgi CFG files and is able to convert them into the Wicked configuration. And we will also provide if-up wrapper scripts, so you can completely replace the old sysconfig stuff we have in OpenSUSE now with Wicked behind. And we don't want to conflict with the existing infrastructure. But replace it and provide the legacy world, also the legacy interfaces like if-up, at least in the first time. Yeah.
A question on the config files. I mean, the differences between the red and the green IFCFG files are not that big, but would it also be feasible or possible probably to also read, for example, Debian config? Because I mean, that's another part of the world which would probably be good to also have support for.
Yes, of course.
Or do they? I'm not. Didn't work much with it, so maybe they have totally different set of features that's not easy to implement. Or did you think about that too?
Yeah. It's not a problem to add parser for Debian config files, which converts the Debian files into Wicked. Of course, when you want to use the Debian config and start Wicked with the Debian config, using the Debian config, then you are limited to the features that are supported by both. But this is, this is the migration time.
Well, yeah, I mean, the reason it's currently supporting only these two flavors is because, of course, I started with the SUSE format, and the Red Hat one is reasonably similar, so that it wasn't a big hassle to add support for that stuff too. Debian is just another flavor, and I mean, basically it all boils down to talking to the kernel and using the kernel features, so I don't think there is anything outrageously different from a semantic point of perspective.
There are some differences between the green and red if CFG files. For example, the green one in bonding, you specify the Ethernet interfaces, and on the red side, each Ethernet interface specifies the bonding. So it's another way around, logically different, but it's just a question of converter. Basically, we have in the deep put each interface to some path, at some path. And for example, there is a loopback device and the first Ethernet device, which usually has the if index 2. And this makes it sure that when the interface changes the name, it's not a problem for us to handle this. We just need to update the name flag in the interface, so we don't rely on the network interface names. On the another side, we have the problem that without existing interface, we cannot create this part. And for this, we have something like a factory where you can request to create the interface. And we associate each with a link layer type, like loopback is native loopback, and Ethernet devices has native Ethernet. On the there are some methods for each object, and these are the common methods like firewall up, firewall down, change device, link up, link down, network, then request list, drop list. And finally, we have the configuration of the network interface. The name flag can be used to identify the interface, but must not be. There are some another possibilities like identify tag to match, for example, by MAC address or by PCI bus number or whatever. So you don't need to rename the interface using QDEF rules, but you can match it to some configuration by rule. And then you can specify some alias to the interface and have a constant name for this. And each part of the layer that we have in on the interface is in a separate node in the configuration. For example, specific attributes are in Ethernet, link-specific attributes which are common to all interfaces are in link, firewall in firewall, and yeah, IPv4 and 6 with static and DHCP, which can be also mixed together. So you can use DHCP but add statically addresses also. Yeah.
I wanted to add one remark here. I talked a lot about layering and why it's important to do so. And this slide here, it shows essentially the layering approach that we're taking with the interfaces. So the only part that is really specific to the Ethernet link layer is the very first class up there and the change device method. All the other ones are generic. So supporting a new interface type just means you have to add one basic dbus class, one dbus interface for this link layer type, and you inherit all the other methods. And similarly, if you want to introduce a new functionality, a different layer, for instance, after all the addresses have been discovered, you need some specific activity to happen for all interfaces. You just introduce another dbus interface that applies to all link layers. And there is no messing with scripts or hand coding something with daemon. You just add that new dbus interface and say, okay, you apply to all link layers, and then you go, and all of a sudden this stuff will also be handled across the board for all interface types. So that's the whole beauty of the concept, that it's very extensible in both ways. So both in terms of adding new link layers and in terms of adding new protocol layers somewhere in between or on top of it.
Yeah, current state of the project is it's source only at the moment. You can get it from Gitorius. We have some packages in OpenSUSE build service, but you have to take care when you install the current packages you may find there, because in SUSE at least they conflict with sysconfig and network manager. So when you know what you are doing, then you can use the packages, but at the moment it's a little bit chaos. We have implemented Ethernet, wireless, VLAN, bridge, bond, and this is almost complete, or fairly complete. We have a lot of code for the wireless support. We communicate with the WPA supplicant and can use it. There are still some problems, and in last time there was some bug, so it maybe when you tested 2 months ago or 1 month ago, it maybe didn't work. We have first Open VPN support. It may work. We are using, or we are supporting modems already, but it's also in some early state. We have built-in DHCP4 and DHCP6 support, also zeroconf support, autoconf, and static addressing. There is still a lot of work to do, but it basically works already. IBFT, iSCSI boot firmware table. We have the support, but we didn't test it until now. IBFT allows you to set up the network in the BIOS. So you set up in the BIOS if it should use, for example, static configuration, if it should use DHCP or whatever, and you have to read it from the BIOS, this configuration, and use it in the system. And usually you mount the rootfs using the information, the BIOS, which supports eBFT, is able to boot directly over the network. And in Wicked, you have to consider this, that you never shut down this interface, for example. And you have to make sure that you are renewing leases, for example, and don't throw away the IP address of eBFT and so on. We've tried to update the documentation, and it's something like current at the moment, but there are still some old parts which may be outdated. But this is what we are working on. Next steps are to work with the OpenSUSE community to integrate this into the system. We have to improve the documentation, create packages which can be installed and used, and when you boot the system, it works, at least in the simple cases. And then there are more advanced targets that we have to implement, is support network authentication or Ethernet interfaces 1.x and LDP and firewall support, and improve also the IPv6 support we have, because at the moment it's limited similarly to the ISC DHCP client, for example. We can do similar things. For example, handle only one IP address. But what we want to do is to handle also temporary address and non-temporary address at same time and so on. And this is a little bit more complicated. And we have to integrate with systemd. Yeah, and then there are several things that need to be adopted, considered, and so on, like virtual interfaces of some guest machines, libvirt, Open vSwitch, and so on. Yeah, any feedback and help to this project is welcome and very appreciated. Yeah, thank you. Are there some questions about this?